What is field? A field is a region of space where the influence of, let me just say, physical agency is experienced, as you can see. But what are the physical agency we are talking about? Physical agency might be force, and we have different type of force as far as field is concerned. We have the electric force, we have the gravitational force, we have the magnetic force. But in this case, I'll be talking about electric field actually. And if we are talking about electric field, that's the a region or space where the influence of an electric force is experienced. That is where the influence of electric force is dictated or can be felt. Electric force can be dictated or experienced between two charges, depending on their on the nature of the charge or on the type of charges that is present. We can classify electric force into two types. The first one is the attractive force, and also the second one is the repulsive force. If you have two electrons that are they are of the same time, that is they are of the same kind, that is they are the same, we are going to experience a repulsive force. Let's say we have positive and positive, we are going to experience a repulsive force. But if we have electron, let me just say we have charges that are of different kind. Let's say we have the positive and also the negative, they are going to be they will attract each other. That means the kind of force that we are going to experience or feel between the two charges is going to be an attractive force. So electric field is just a region of space where the influence of an electric force is experienced or can be felt, detected. Now, an electric field is a region, okay, I've explained that. So the magnitude of electric force between two electrical charged body is given by the Coulomb's law. Coulomb's law is just a law that is put forward to calculate, let me just say calculate, or let me use estimate the magnitude of force that is experienced between two charges. Let's say you have two charges, Q1 and Q2. This Q1 is positive in nature, and we have what? Q2, charges Q2. Both of them, they are actually placed beside each other. That is, they have a little distance between each other, and the distance is what is known as the R. She gets right down. Let's say from here, from this point to this point, the two charges are placed beside each other. Q1 is positive in nature and Q2 is what is, let's say, it is negative in nature. Or let me just say, I don't care about their nature, maybe it is positive or negative. But in this case, now to experience these two charges, that is actually going to feel some force between each other. You know, it might be this is attracting to this, or this is what is repulsive to this. So the magnitude of the two charges, the magnitude of the force that is experienced between the two charges is calculated using what? Using Coulomb's law. And Coulomb's law says that the magnitude of the electric force F is directly proportional to the what? To the magnitude of what? Of the two charges, that is to the magnitude of what? Of Q1 and magnitude of what? Of Q2. And inversely proportional to what? To the square of the distance between what? The two charges. In just short, you can just say, okay, when two charges are placed beside each other, the magnitude of the force that is experienced between the two charges is directly proportional to the magnitude of the, to them just say, to the product of the magnitude of the two charges, and inversely proportional to the square of the distance between the two charges. And the thing is that this one we are representing, we use magnitude, is that we don't care about the sign, maybe it is positive or negative. That means we don't care about the nature of the charge. It might be positive or negative, but the numerical value of the charge doesn't depend on the nature of the charge. That means you don't need to put minus, or you don't need to put what? Plus, since you are using magnitude. Then in this case, to remove our constant of proportionality, we need what? We need our constant. That's a constant of proportionality, which is what? K. Check it down. And our K is given by what? That is given as 9.0 times 10 to the power what? 10 to the power 9 in Newton meter square per Coulomb what? Coulomb square. Because if I just have that, I'm going to have my electric force to be equal to what? That's KQ1. Let me just say K magnitude of what? Of Q1, then magnitude of what? Of Q2, all divided by what? R square, which means that my F is directly proportional to what? To the constant of proportionality, and also to the product of the magnitude of the charge, and inversely proportional to what? To the distance between the two charges. Now my K, I can actually express it as another time, or in another form. I can have my K to be equal to K to be equal to 1 over 4 pi epsilon naught, right? My epsilon naught is actually emissivity or emissivity of free space, and it is given by what? E naught, which is equal to 8.85 times 10 to the power what? Minus 12 Coulomb square per Newton meter square. That's just my emissivity of the free space, and my q1 and q2 is known as the what, the magnitude of the charges, and my r square is what is taken to be the distance, the square of the distance between the two charges. And don't forget, these two charges will actually what felt some force, that is, they will experience some force between each other. The force might be can be attractive or repulsive. If it is attractive, that means they will move inside, inward, with their arrow is going to move inward with each other. But if it is repulsive, the arrow is going to point outward with each other. You understand it now? So the magnitude of the force that is experienced between the two charges is calculated using what? Using Coulomb's law, which is F equals to K Q1 Q2 over R square. Now let's just move to some question I'm having here for you guys. Now look at the first question I'm having, which is question 1. The question is, what must be the distance between point charges Q1, which is equals to 4.0 microcoulomb, and point charges Q2, which is equals to minus 30.0 microcoulomb. For the force of attraction between them is what? 3 Newton. Let me get my calculator. 3 Newton. Then we are having option A to be 0.6 meter, and option B to be 60 meter, and option C to be 14.8 meter. Then we are having our option D to be equals to 2.05 meter. Now in this case, actually the best thing to do is that in this kind of situation, you are given OBJ, and we are in civilized, what can I just call it, civilized, is it not the best? So you might not, they might just say you are not going to use calculator, then you should know how to calculate without using what? Calculator. But in this video, I will help you to simplify it in such a way that you'll be able to calculate without using calculator. So now let's just go ahead. Here, what must be the distance? You are giving, we asked calculator what? For the distance, which is what? Our R, right? What must be the distance between point charges Q1? What's my Q1? In this case, my Q1 is given by what? That's 4.0 microcoulomb. And don't forget that our micro is actually what? 10 raised by what? Minus 6. Our nano and our pico, we have nano to be equal to 10 raised by what? Minus 9, and our pico to be equal to what? 10 raised by what? That's minus 12. That's just what I've done. So in this case now, what must be the distance between point charges Q1, which is 4.0 microcoulomb, and point charges Q2? My Q2 is what? Is minus 30.0 microcoulomb. For the force, electric force of attraction between them is what? Is my F is what? Is 3 Newton. So in this case, the question is somehow direct and straight. So we just need to recall our Coulomb's law, which is F equals to what? That's K Q1, right? Q2 over what? Over R squared. But in this case, I'm giving my F to be what? To be 3 Newton, right? Equals to what's my K? It's actually a constant value, which is 9.0 times 10 by what? 9, right? Multiply my Q1 is what? Is 4.0 times 10 by what? That's minus 6. Then multiply again by what? My Q2, which is minus 30.0 microcoulomb. But I don't need to consider there was the negative sign, because by the time I find the magnitude, don't forget that my magnitude is here. By the time I find the magnitude, it's still what? Positive. Then I'm going to have 30 times 10 raised by what? So that's minus 6, right? All divided by what? My R squared. So making my R squared the result of formula, I'm going to have it to be what? To be R squared equals to what? That's 9.0 times 10 raised by what? 9 multiplied by what? 4.0 multiplied by 10 raised by minus 6 multiplied by 30 multiplied by 10 raised by minus 6, right? Then all divided by what? That's my 3. Then the best way to just do this is just 3 goes in this, and I'm having what? I'm having 3 here, right? So that I will have, that's 3 times 10 raised by what? 9. That's multiplied by 4.0 times 10 raised by what? Minus 6. Then multiply by what? 30 times 10 raised by what? That's minus 6, right? All divided by what? I'm having 1. That's just very good. So let's just find a way to just simplify this. Then if I just go ahead and multiply 4 multiply by 30, that's give me something like 120. I'm right. Then my 3 multiplied by 120 is going to be what? That's 360, right? I'm going to have something like 360 multiplied by what? 10 raised by what? 9, right? Multiplied by 10 raised by what? Minus 6 multiplied by 10 raised by what? Minus 6 rather. So here I'm having minus 12, right? Minus 6 minus 6, that's actually was minus 12 using indices. Then 9 minus 12 should give me something like what? That's 3. So I'm going to have 360 times 10 raised by what? That's 10 raised by, that's minus 3 rather. So I will have something like this. That's my r square equals to 360 times 6 power minus 3. So here I just need to simplify. My this is 1, 2. I can just see this is actually r square equals to what? 360 multiplied by this should give me what? 0.36 exactly. So if I'm having 0.36 here, I need to find the root of 0.36, right? So how equals to root of what? 0.36. Then I can just express that as what? As root of 0.01 multiplied by root of what? 36, which is equals to what? 0.1 multiplied by what? That's 6, which is what? 0.6 meter. Can you just see the? Can you just see it now? So my answer is what? Is A. So I'm having A here. That's my right answer. So that's just how you can calculate some things without using calculator. Very simple. Just need to apply some rules in mathematics. So now let's go to the second. Let's move to the second question. Yeah, a point charge of 45 microcoulomb is 20 centimeter distance from the second point charge of minus 3.0 microcoulomb. What is the magnitude of the force on the charge? Here we are asked to calculate for the magnitude of the force. That's F, right? Using the same, apply the same formula. I'm going to have F equals what? KQ1, right? Q2 over R square, right? So my Q1 in this case is actually what? That's 45 multiplied by what? 10 raised to power minus 6 because I'm having microcoulomb here, right? Then my Q2 will be equals what? That's minus 3.0 times 3 raised to power what? My 10 raised to power minus 6, right? Microcoulomb, right? And I'm having my R to be what? That's 20 centimeter. That's 20 times 10 raised to power what? Minus 2 rather. Right, so now let me just go ahead and substitute the value into the formula. I'm going to have my F to be equals to what? That's 9.0 times 10 power what? 9, right? Multiply by what? This, which is 45 times 10 power minus 6, then multiply by what? That's 3.0 multiplied by 10 power what? Minus 6 divided by what? That's R square, which is 20 times 10 power what? Minus 2. So I just need to go ahead and try to do something there, simplification, right? So here I'm going to have my F to be equals to, that's let me just say this, I'm writing this as 9.0 multiply was 45, right? Then multiply by 3, multiply by 10 raised power was 9, multiply by 10 raised power minus 6, then multiply by 10 raised power was minus 6, right? Then here I'm going to have, don't forget this is what? All square. I'm going to have all divided by 20 square. Can you see this? And multiply by 10 raised power minus 2 square. Can you see it's very simple? So I can just go ahead and just solve it using normal method. Here 9 multiplied by 45 multiplied by 3. Your computer calculator should be able to solve that one. That's 9 multiplied by 45 multiplied by what? That's 3. I'm having what? That's actually 1215, right? So I'm having 1215. Then multiply by what? 10 is power what? 9 minus 6 minus 6. All divided by what? 20 square will give me what? That's 400. Then multiply by this square should give me what? That's 10 raised power what? That's 4. 10 raised power 4. I should have something like 10 raised power 4, right? So in this case, I can just go ahead and simplify. Right? Simplifying this, let me just say 10 raised power minus 2 also. Let me confirm it with my calculator so I will not make mistake, right? So what am I having? It's still the same thing. It should be minus 4, not 4. Yeah, right. So let's just go ahead and just simplify this. I'm going to have 1215, right? Then multiply by what? This minus 6 should give me what? That's multiply by 10 raised power what? That's minus 3 divided by what? This should give me 4 times 6 power 2, Abby. This, that I'm having 10 raised power minus 2. Check it down. So I'm going to write this as what? 1215 divided by 4. You understand it now? Then multiply by 10 raised power minus 3. Can you see that? Minus 3, then times 10 is power 2 exactly. If I bring this on to this place, I'm going to have 1215 over 4 divided by 4, then times 10 is power this should give me what? Minus 1, right? Then I just need to press this on calculator and see what I'm going to have. Then 1215 divided by 4, what's that? I'm going to have how that's 303.75, then multiply by what? 10 raised power minus 1. So in this case, this is actually minus 1. Then I can shift my decimal point to the side. I'm going to have 30.375, which is the answer. So the right option is what? Is option E, which is my right answer. So that's just how to solve some things. So let's move to the next question I'm having. So the next question I'm having here is just this. Look at this now. They say, what equal positive charge would have to be placed on the Earth and on the Moon in order to neutralize the gravitational force of attraction between them? No, as far as we are talking about the gravitational force, it's actually an attractive force. You understand that? And Earth and the Moon, they experience what? a gravitational force, which is an attractive force, then the question now says what equal charges, equal positive charges must be placed between the earth and the moon so that they will experience a neutralization, like they will experience in order for the force to be neutralized. Now look at this. Now what equal positive charge? Now that means you don't know the equal positive charge. That means you are asked to calculate for our q, positive q, right? Then is unknown. Then it will have to be placed on the earth and on the moon in order to neutralize the gravitational force of attraction. Neutralization, that be. So we are having our mass of the electron to be 5.98, right? Multiply by 10 raised power to 24. Then we are having what? Our mass of earth, rather mass of the moon, we are going to have it to be 7.36 times 10 raised power what? That's 22, right? Then we are giving our gravitational force to be equal to what? Gravitational constant 6.67 times 3 raised power minus 11, right? Then here our electric force constant is what? That's 9 times 10 raised power what? 9, exactly. So now let's go ahead and solve this question. So here, what's equal positive charge? How can I just go with this? I can just say this is my what? My KQ1, right? Q2. Let me just say this is Q1 and Q1 because they are talking about equal positive charge over what? Over R square, right? Equals to what? My this will be what? G, which my this is actually for the electric force, and this will be GM, mass of the earth, then mass of the what? Of the moon, divided by what? The distance between the what? The mass of the earth and the mass of the moon. So here, this you cancel this, right? Yeah, right. So I'm going to have my q square. This one will be kq square, right? Kq square equals to what? That's g m e m m, right? Then divide both sides by k, because I'm asked to calculate for the what? For the charge. So that I'll have my q square to be equals to what? G m e, right? M m over what? Over k. Then very good. Now let's just go ahead and use this formula. Applying this one, I'm going to have my q square to be equal to what? G is what? That's 6.67 times 3 power what? Minus 11, right? Multiply was me, mass of the earth, that's 5.98 times 3 power what? That's 24. Then multiply was mass of the moon, which is 7.36 times 3 power what? 22. Yeah. Then all divided by what? All divided by k, which is 9 times 10 power what? 9. So in this case, I'm not going to be using simplifying anything because let's just go ahead and solve it directly. That's 6.67 times 10 power, that's minus 11. Then multiply by 5.98 times 10 power, that's minus 24. Then multiply by 7.36 times 10 power, that's raised power 22. Then all divided by that is 9 times 10 power 9, right? So I'm having 3.26 multiplied by 10 raised power 27. Oh god. So let's just go ahead and find the root. Finding the root, I'm going to have q to be equal to root of what? Root of 3.26 times 10 raised power 27. So my q to be equal to, my q is equal to, that's root of 3.26 times 10 raised power 27. That's 5.7. That's 5.7 times 10 power what? That's 13. So the right option is what? Is option C. The reason I didn't choose to just simplify is that there's no space for me to simplify, because you understand now. So let me just use the calculator directly. So let's just go ahead and look at the last question I'm having here. So find the ratio of the Coulomb's electric force to the gravitational force. Here we are dealing with two forces. We are asked to find the ratio of the Coulomb electric force to the gravitational force. That means our Fe, right? Ratio Fg, gravitational force, right? And we know our Fe to be what? Kq, right? 1, Q2, what? R square. But in this case, look at this. The question is between two electrons. Do two electrons in the vacuum? That means if two electrons is in the vacuum, that means their magnitude is what? Is equal. Actually, that means we take the magnitude of Q1 and Q2 to be equal. That means I can just say this one is of no identity. Both of them are actually what? The same, which is what? Q multiplied by Q, which is Q square, divided by R square equals to what? My gravitational force, which is G M E over what? Over R square. Right? This will cancel this. I'm going to have K Q what? Q square equals what? G M E. Okay, let me just say this M E square, because I'm only having one mass of proton here. So I'm going to have GME square, right? So we need to divide them to, we need to get, that's ratio, right? We need to divide them. Then I'm going to have my what? My KQ square, right? Divided by what? That's GME square. Because I'm asked to find the ratio of the columns to what? To the gravitational force. So here I'm going to have, that's 9 times 10 to the power 9 multiplied by what? That's Q square should give me 1.602 times 10 to the power minus 19 all square, right? Divided by what? Divided by GME, which is my gravitational force constant, which is 6.67 multiplied by 10 to the power minus 11 multiplied by what? My ME, that's 9.11 times 10 to the power minus 31 all squared. So in this case, I'm going to be separating this. I'll separate them. I'm going to have 9 multiplied by 10 to the power 9 divided by 6.67 multiplied by what? 10 to the power minus 11. Then multiply by what? I'm going to put this one, you know, they are of the same square. I'm going to have 1.602 multiplied by 10 to the power minus 19, right? Divided by what? 9.11 times 10 to the power minus 31, right? All square. Yeah, let's just look. Let's see. I'm going to simplify this. I'm going to have 9 divided by what? 6.67, right? Then multiply by 10 to the power 9, right? Then plus 11. Very good. Then multiply by, open a big bracket here. I'm going to have 1.602 divided by what? 9.11, right? Multiply by 10 raised by what? Minus 19 plus 31 all squared. Then let's just go ahead again. 9 over 6.67. I should be able to use my computer calculator for that. That's 9 point divided by what? 6.67. So what am I having here? I'm having 1.34. 1.349, right? Let me just say 1.35, okay? Multiply by 10 raised by what? That's 20. Multiply by, open another brackets, 1.602 all divided by what? 9.11. I'm having 0. Something as 0.17, right? 0.18. Let me just say, go ahead and use 1.8. Multiply by what? 10 raised by what? Minus 19, then minus 19 plus 31 is actually about 12, right? So I'm having 10 raised by what? That's 12 all squared, right? So now let's go and simplify. 1.349 multiplied by 10 raised by 20 multiplied by 0.18 times 10 raised by 12. I'm going to have it to be 0.18 squared, right? Multiplied by 10 raised by 12 squared. Can you see this now? So let's just go ahead and simplify this. I'm going to have 0.18, then multiplied by 0.18 is actually, that's 0.0324. I'm going to have 1.35, then multiply by 10 raised by 20, then multiply by what? That's 0.0324. Then multiply by what? That's 10 raised by what? That's 12 squared, that's 24. Right? So now let's go ahead and use direct calculator. I'm going to have 1.35, then multiply by 10 raised by what? That's 20. Then multiply 20, then multiply by 0.0324, then multiply by 10 raised by 24. So I'm having 4.37 times 10 raised by what? That's 42. So here, since my FE ratio what? FG, here I'm having what? This and this, show that I'm going to have what? This is 1 ratio, that's 4.37 for multiplied by 10 raised by what? That's 42. So the best option and the right option here is actually, let's go for B, because I have 1 ratio 4.2 times 10 raised by 42. So alright guys, this is the end of the video. Hope you enjoy it. Our next video will be on how to calculate some electric charge that are placed beside each other. Let me just say the force of attraction or the positive force between electric charge beside each other. You understand it? And how to just, let me just say, the solving of forces into their components, into their respective components, be it vertical or horizontal. So if this is your first time watching my video, please kindly hit the subscribe button. Make sure you subscribe to my YouTube channel, and feel free to drop your question in the comment box